Hello, everyone. Welcome back to our YouTube channel, Becoming a ROS Developer, here at The Construct. My name is Rodrigo, and today we have one of our students, Peter, who has completed the two courses, actually, and we might see both, the project for both. These courses are ROS2 Basics in 5 days and ROS2 Navigation in 5 days. And at the end of these courses, what we do is we encourage students to do a presentation in order to get our certificate of learning. And so, and this presentation is actually implemented on a real robot here at The Construct. So that's what we're going to be seeing here today from Peter. So, hello, Peter. How are you?
I'm fine, thanks.
All right, awesome. Nice to see you. So, whenever you want, please start sharing your screen, and you can just show us what you've done with your project and how you have solved it.
Okay,
Awesome.
I'm
We can
sharing
see
my.
your screen.
Okay, cool. So I will start it first. And we will see what it does.
Great.
Okay, just some seconds for Ervis to start. You see.
I see.
Pop. Yeah. So no map yet. Now I'm starting my. It's a worker. Basically, what it has to do is walking round and round from one corner to the other one in a counterclockwise direction. So first it checks where the balls was where the algorithm thinks that there are corners.
Corners of
And
this
yeah,
environment.
yeah. So here is the next corner, and one ball with a bit red is the corner where the robot wants to go next. So pretty much I named it as a Petro robot because it goes round and round from one corner to the other one. I think let's see, because now it's finished the goal, and we'll check again the corners after that, and we'll find the next one. Okay, here the corners. Okay. It wasn't successful to find the next. Okay, the corners and the next. At the start, when I think when the map is not stabilizing enough, it is not behave well. But after that, I think now from the second or third corner, it will stabilize and going only counterclockwise. We will see it.
Mm-hmm.
It should stop frequently because so there are errors in the planner. It lost some frames. I think it's a bit slow. Something is slow probably. I didn't tune it well. So you see it doesn't find valid points, so it is waiting now. Okay, it has the next corner and goes to there. And yeah, and basically it should avoid objects. Please do that. And it wasn't successful. Interesting. Yeah, there is object avoidance. I didn't do anything about that. I just use the templates.
Mm-hmm. So it will keep doing this forever?
Yeah, hopefully, yes. It's a
Okay.
patrol robot. It just goes round and round. That is, I think the interesting part of the algorithm is first because how it detects the wall. It's some geometry. So it based on the laser measurements, it tries to find a rectangle, the biggest rectangle or the smallest rectangle, which is set by the laser points. So it finds out the room sizes and the walls,
Uh-huh.
and after that it finds out the corners of the walls, and that is.
Nice.
I can show you in my presentation about how it works
Yes, could you
in high
please
level.
tell us
Yeah,
uh
yeah.
how
But
you made
I
this
think I
work?
can share only one screen so you can see the robots, all my presentation. This is so my presentation or the robot.
I'm sorry?
Okay, I have a presentation, but
Yeah,
I
yeah, please
think I
continue. Yes, yes, show it to us, please.
yeah, but I think at that case I cannot show you the robot.
That's fine. We've already
Okay.
seen the behavior of what you've done, so let's take a look at how you've solved it.
Okay.
You can just leave this running in the background, I guess.
Yeah, hope it will run. Okay, just a second. I have to reshare it. Ah,
No, I was seeing it before you did that.
you saw that?
I can see ROS2 navigation plus Python.
Okay, this is
Hmm.
so. So the robot is go round and round, that's in counterclockwise direction. So no need a map in advance, no need to know the room sizes, no need to know the robot position in the room. Hopefully, it's okay. And the automatic object avoidance, it's in navigation, of course. The room must be rectangular. This is the only one fact that but the robot needs in advance, so it doesn't work in an a round or I don't know, an octagon room. It doesn't work in that.
Okay.
And it uses only laser scan for the navigation, but it does it first. It detects the wall, then choose the closest corner and navigate to it to that corner. And after that, it does in a loop that detects the walls. It always should detect the wall because you know it can be the if the room is full of objects, maybe the laser scan doesn't show precisely the walls. If there are many objects in the room, maybe the laser doesn't touch the wall. So in
Uh-huh.
that case, the robot thinks that the room is s- smaller than in a real world.
I
So
see.
when it reaches the goal, it always detects the walls again, and then choose the next corner and navigate to it. That is. So the leader is I I can tell you how I detect the walls. So the leader is in the center of the frame, and let's see the simpler case when the walls are parallel to the x or y axis. Yeah. So this is the robot in the.
Uh-huh.
Can you see
Yes, I
my
can see it.
mouse?
With your mouse, yes.
Yeah. Okay. Cool. So the robot is in the center. This is the x and this is the y axis, and let's say that these are the laser points. I mean the ranges what the laser scan detects.
Yes.
Okay, so see this is the room basically. I have to get all the laser points x-axis maximums and the minimums here, and also for the other axis. This is the minimum. Sorry, this is the maximum and this is the minimum. So the predicted walls is these are black lines. Okay, clear? I think.
Very clear. Yes. So you take
Okay.
out the max and mins, and then based on that, you just draw some lines.
Yeah, this is. But this is the simpler case. So maybe the robot is not in parallel with the x or y axis. Let's see
Yes.
this. So maybe the room is something like this.
Mm-hmm.
So what I have to do is doing the same process as was before, but I have to rotate a coordinate frame a bit. I may say that it's enough to rotate the coordinate frame 90 degrees maximum, because it doesn't matter the robot for which axis is parallel, a y or a x. So it no need to rotate in 360 degrees all the laser points, just between 1 and 90 degrees. So
Okay, yes.
here it is. So let's say I am rotating a frame a bit. So this was the first guess for the walls. This is the, can you see?
Yeah,
Yeah.
I can see.
Okay. So, and I counted the area of the rectangle. Then I rotated a bit again. This is the second guess for the room, and this is the third guess for the room. The real room is where this area is the minimum. So in that case, I know the room was in the rotated keys also. Okay.
Uh-huh.
Yeah, if I had an obstacle about that. In simulator, there was the leader is a bit different than in the real robot. You know the in
Yes, I do.
okay
Yeah.
okay. So I wrote a wrapper for that, which is
Oh, nice.
always give me the simpler cases with 360 ranges and the angles between 0 and 2 pi. So I I think it is, yeah, it was easier than writing ifs, branches in the code.
Absolutely.
Okay, how to do this counterclockwise? Yeah, so first I found the corners, and then if I found the corners, all the four, I sort it in a counterclockwise manner, and then I just store the actual index of the corner and go to the next one. I'm increasing the index of the corner. So this is how it goes counterclockwise. Oop. And that was all about the presentation. So let's see. Okay, it goes. Yep,
It's still going.
it
All
works.
right. Awesome. Is that it for your presentation, Peter?
Yeah, we can talk about a bit about the code if you want, or
I have some questions, yes.
okay, cool. Yeah,
Awesome.
please.
Do you mind, while we talk, you and I, do you mind stopping sharing your screen so we can sort of
Okay.
have each other on the screen here? So first of
Okay,
all, really nice project. Congratulations, really interesting. Um,
thanks.
I liked, uh, very original, and I have some questions. Uh, so the first thing is basically the project instructions for the ROS2 navigation in 5 days was to add navigation to set up your nav2 stack and then build an application on top of that where you would save some spots and send them to there. One was a bunch of corners, there was a pedestrian. So
Yep.
in your case, you did something different. Uh,
Yeah, I did.
so my question is this detection of corners and then sending I'm assuming that was an action client. Is that your application on top of of the nav2 stack? Is that what you've done
Yeah,
as
of
the
course. Yeah,
application on
I'm
top?
sending these goals to the navigation stack. Yeah.
Okay. My first question is, I noticed that there was a map, but it wasn't created. You were launching it, and behind there, I'm sure it was G mapping or cartographer or something making
Yeah.
that map. So my question is, because it's a little bit outside of the default behavior, which is you should you load a map with the map server and then you use that with navigation too. How were you able to navigate without a map?
Yeah, first I had a map. Then I was thinking about that. It's totally unnecessary because I thought that when we are creating a map, we have to navigate the robot manually around the area. So I
Yes,
was
to
thinking
make
about
it.
first that why not the robot goes automatically and creates a map because it's the same basically when I manually direct the robot to go here and there, but instead of that, the robot can go to randomly here and there. And then I was thinking about that it's also unnecessary because a robot can start to go round and round. If it's not a corner, I mean it's not a real corner of the room, it doesn't matter. Okay, it's just a bit strange behavior at first, but after a while it should go round and round because it will go to the every corner of the room
Yeah.
after a while.
And what is the so what is missing in the beginning when it's doing some weird things you're talking about? What is missing in that scenario? And then you rely on it to work for it to actually go to the corners. What is
Yeah,
this
there is
process?
no global map. I mean, there is not a 100% good global map at the first.
Right, right. So that means that the robot doesn't really know where it's at.
Yeah, it doesn't know. Yeah, it just thinks something that but it's not important for a patrol robot.
No, yes, I understand. I'm just trying to kind of break down your logic here.
Ah,
So
okay,
in the
but you're right.
beginning,
Yeah,
your robot is not localized correctly. That was my point,
sure.
right? So
Yeah,
it's
yeah,
as
right.
as you set goals, even if they're incorrect, it'll eventually find its way there
Yeah,
because um, of that. So then you needed to send those coordinates with respect to something, with respect usually to the map frame
yeah,
and the
yeah,
coordinates. How did you get those coordinates in order to, you detected that corner, then you must have moved it a little bit backwards, and then that was the coordinate that you sent the client to.
yeah, yeah. This is.
Okay.
I know the corners, and I count 30 centimeters into the inner side of the room,
I
and
see.
that is a
I
corner.
see. Just a nice question because a lot of people might be interesting. I noticed that you actually published the corners that you find. Can
Yeah,
you tell us how you've done that in Arvis, really quick?
yeah. It was it was fun with markers. I didn't know that they are exist, but I checked on the internet. Yes, they are
Yes,
exist. So
yes.
it's very cool.
Very
It's a
useful
marker
to
array.
for
Yeah,
helpful
it's
for
very useful.
especially for debugging because at the end of the day, Arvis is just for us uh, to as
Yeah, at the beginning, I didn't transpose the laser coordinates to the map well, and I saw with these markers that it was totally out of the map
yes.
and never or very far from the robot. So I can detect the bugs.
And all right, cool. Let me see what else I wrote here. So you talked about writing a wrapper, unified laser scan or something.
Yeah, sorry for the name.
No, no. I mean, I like it. I'm just interested. How did you do that? So
Now, yeah,
what are you doing? You're doing the length of the array, or what are you doing there?
it's easier than at first at
Uh
first
huh.
thing. I what I was did. Yeah, I it we have only two cases here, so I didn't do it in absolute generally because I don't know anything about the laser scan. So when it realized that there are only 360 um, ranges, it just uses that.
Uh
I
huh.
mean, but if it realized that it's the other
720.
case, yeah, it's the other case. It, uh, it yeah, it made some transformation with the degrees, and it simply drops every second measurement. Yeah, it's a very tough. I know it's very tough, but it's quickly and
Okay. Yeah,
works.
yeah. It's quick. Uh-huh. Uh Just for future reference, this is not part of the course, but it's interesting in case you're working with simulations. It's very simple to go into your simulation and adapt your plugin to change
Yeah,
it. But again, this is for your next course you take with us, the gazebo, in case you don't know about it. But yeah, that's a great way of handling these things, because the real robot in the simulation, most of the times, no one has time to do both things exactly the same. So all these things will change. So awesome. So you basically, one thing we did see as well was the last crash there that we have against an obstacle. And that might be for two reasons. One thing is, I'm sure you've noticed that for some reason in this remote configuration, sometimes you can, sometimes you can't, sometimes not at all, can't see the local cost map or global cost map of your navigation setup. They just don't appear. So that's harder to see in the real robot, whether or not your local planner or replanner, I guess, in case there's a dynamic obstacle, is actually doing something. Did you know? I mean, it must have been running. Otherwise, Navstack, I don't think it runs. No, I think it does. But my question is it able to avoid dynamic obstacles? Maybe when you were...
you know, it should. It is the navigation stack.
Yes.
When I'm working on the simulation, I saw the local and global cost map, and it is changing well. But you saw that it goes to it went to an obstacle.
Well, my guess here though is that the actual base of the obstacles is not the same as what the LiDAR is seeing, which is just the stick.
Yeah.
So the inflation layer might actually not encompass the whole obstacle. That's actually intentional on our side. So maybe that was the issue. But I mean, those are all the questions I have. Really nice, really streamlined. It shows, I mean, it is a little different from the project we have available, but I like that. I like that you did a little bit of a different approach, because it shows your understanding of the basic concepts we're trying to teach in this course here. So really, really nice, Peter. Congratulations. So really good job. I really enjoyed looking, and maybe it's still running in the background there, because your goal, like you said, was doing a patrol.
The session is over.
Oh, the session's over.
Hopefully it stopped.
But congratulations, Peter. Really nice job here with your project for Nav2.
Thank you.
All right.
I enjoy very much your courses.
Oh, I'm glad to hear that. That's what we're here for. We're always trying to improve upon them, and hope to see you around for a couple of extra projects that we offer around our website.
Cool.
Thank you. All right, guys. Let me just switch back to my screen. This is what you can do if you take one of our courses and want to get one of our certificates of learnings. These certificates mean a lot to us, so we ask for you guys to do what Peter did here and come and present your learnings in a presentation here with a real robot. So I encourage everyone to do what Peter did here to keep pushing your ROS learning. And that is it from us, guys. So I hope to see you again soon for the next presentation, guys. And thank you, Peter, one more time. Hope to see you again as well. All right, guys. We'll see you guys in the next one. Bye-bye. All right, cool. We are done.